Hi everyone, how's it going? Hope we're having a good day. So this is a continuation of what we did not finish in class yesterday. We started talking about this new type of chi-square testing, and so let's just recap really quickly. We were talking about comparing St. John's wort to Zoloft to placebo and seeing how it worked with people that have major depression and what kind of responses they got. These were our observed counts. I made a little note here. Eventually we're going to put these in a matrix in our calculator, and I'll show you how to do that here in a little bit. We said that we can't use a goodness of fit test like we learned in the last section because we're comparing more than one sample with more than one category. Okay? So then we went further. We calculated some conditional distributions. We said we would want to use these proportions instead of counts because there weren't equal numbers of subjects in each category, or in each treatment, I should say. We said we would use a bar graph if we ever wanted to make a graph for it. And then down here, we found our expected counts by figuring out the proportion and then timing it by the total of that column. So there's 91 in this full response out of the 338 grand total, times that by 113. So that's where that came from. And those are our expected counts. It's okay to have decimal places. So, talking about our hypotheses, we wrote those yesterday. And the last thing we did was we started to calculate the chi-square statistic. Now, to calculate a chi-square statistic, you know you do your observed minus your expected squared over your expected, and you sum. That's a really bad sigma. You sum all that up. Not better, but you get the idea. So we have a lot of observed and a lot of expected, right? We actually have, 3 by 3? There's 9 of them. So write out the first couple. So our chi-square, if I look back on the other side, the very first one, 27 had St. John's wort in full response compared to our observed or expected of 30.42. So I will do 27 minus 30.42 squared over 30.42. And then you can add in the next one. It doesn't matter if you go down the column or across the row. I'm probably going to go across the row. So the next one is also a 27, but that expected was 29.35 squared over 29.35 plus ... Okay. So now we're going to use our calculator. Okay? So, in your calculator, I have a calculator right here. In our calculator, we are going to go to matrix. So, here, it says matrix, so I'm going to hit second, matrix, and it takes me to this place. Okay? Now, these are the names of the matrices. We don't care about that right now. Math, we're not going to use at the moment, but we want to go to edit. This is like when we would edit our list. So, in matrix A is going to be our observed values, our observed counts. Okay? So, only looking at the actual data and not the totals, this is a 3 by 3 matrix, right? 3 rows, 3 columns. So I'm going to change this to a 3 by 3. And then I'm just going to enter them in. Okay, so take a moment and enter those in. So I entered in my data into my matrix A. These are my observed. Now, clear out of that. So, exit out of that, I should say. And now I'm going to do the exact same thing, but in matrix B, I'm going to put in my expected. So these expected values that I calculated, they're going to go into matrix B. So I go back to matrix. Look, and now it tells me that I have a 3 by 3 in matrix A. go over to Edit, go down to Matrix B. It's also a 3 by 3. And then take some time and enter those in. So do that now. All right, so now we have our expected in our Matrix B. So if you go back to matrices, you should see that you have two matrices that are filled in A and B. A for your observed, B for your expected. Now, how does this help us calculate our chi-square statistic? There is a shortcut in our calculator. So we're going to go to Stat. We're going to go over to Tests. And we're going to choose, scroll way down, just the regular old chi-square test, so option C. I'm going to hit enter. And look, it asked me, are my observed in matrix A? Yes, they are. Are my expected in matrix B? I sure hope so. And if you switched it, obviously you can switch it here too. So then I calculate, and it gives me the chi-square statistic, 8.72. Let's call it 8.72. So I've got my chi-square statistic is 8.72. All right. Now it gives me a degrees of freedom is 4, and it also gives me a p-value. We'll talk about that here in a second. Now, degrees of freedom, when it's not a one-way table, so it's not just going to be the number of categories minus 1. That's what we did when it was a goodness of fit. Now we have a two-way table, so it's a little bit more challenging. So to calculate your degrees of freedom, you have to do the number of rows minus 1 times the number of columns minus 1. So degrees of freedom, in this instance, is going to be 3 minus 1 times 3 minus 1. So 2 times 2 is 4. So that's why the calculator said our degrees of freedom was 4. Now we want to calculate the p-value. Now our calculator gave it to us when we did the test, but in case you forget, or for some reason you did this all by hand, to calculate p-value, you would go to your chi-square CDF, and if you remember, chi-square is always to the right when we do our calculations. So first you enter in your chi-square statistic, 8.72. Pick some really big number, and then your degrees of freedom. So if I were to do that, second bars, go down to chi-square CDF, lower is my chi-square, big number, this degrees of freedom was 4, and it gives me 0.068. 5. Let's go to 4 decimal places. Which is what the calculator told me before. So now, we have our chi-square statistic. We know our degrees of freedom. We have our p-value. Interpret the p-value and conclude in context. Okay, so, talking about interpreting p-value. That's what we're going to do first. Okay? Now, whenever you're interpreting p-value, it's always assuming that what you believed was true was true. And then that's the probability of getting what you got. So, we're going to say, actually, I'm going to pause this and write it out and then have you read it. Interpret our p-value. Assuming that the context, or assuming the treatments are equally effective, which was our null, right? Assuming that there's no difference, meaning they're all equally effective. The probability of observing a difference in distributions of responses among the 3 treatment groups as large or larger than the one in the study is about our p-value. So if you need to pause for a second to write that down, feel free to do so. And then concluding in context. So this is where we think about, comparing our p-value to our alpha. I'm not sure if we ever stated our alpha, but we always assume 0.05 otherwise. So, since our p-value is greater than 0.05, we're going to fail to reject our null, which means we do not have convincing evidence that there is a difference in the distributions of responses for these patients. So there's our conclusion once again. Since our p-value is greater than our alpha at 0.05, we fail to reject our null hypothesis, which means we do not have convincing evidence that there is a difference in the distribution of responses for patients with moderately severe cases of depression when taking St. John's wort, Zoloft, or placebo. As always, please be careful not to accept the null as opposed to not accepting the alternative. I know that's confusing. The wording is wonky, but we wouldn't say there's no difference. We just say we don't have enough evidence that there is a difference. Okay? So please be careful about that. Now, there is another example here, example 10. And instead of doing it here, because the space is kind of small, we're going to do it in the next video with all of the examples. So our next video is going to be the notes page that I gave you. So after you finish with this one, we're going to go to that one. This is part of your instructions